In the chapter on confidence intervals, we used the t-distribution to find confidence intervals for the mean when sigma was unknown. So in the same way, we will use the t-distribution for hypothesis testing for the mean when sigma is unknown. So the t-distribution is the distribution of a random variable x that is approximately normal. The t-distribution is actually a family of curves where the degrees of freedom determine the shape of the curve. And the degrees of freedom are equal to 1 less than the sample size. And as the sample size and the degrees of freedom increase, the t-distribution approaches the standard normal distribution. Now the steps for hypothesis testing when we don't know sigma are very similar to the steps when we do know sigma. There are a few differences though. First, we need to specify the sample standard deviation. We need to identify the degrees of freedom. We are referring to a different chart for the critical value. And the formula for the standardized test statistic is a little bit different. So we'll be solving by hand using the rejection region method, and we will not be solving by hand using the p-value method. However, we will be using the calculator with the p-value method. Here is the table for our critical values. Now, to find the right value, we have to specify the level of significance, the degrees of freedom, and whether it's a left-tailed, right-tailed, or two-tailed. Number 1 says, the IRS claims that the mean wait time for callers during a recent tax filing season was at most 15 minutes. A random sample of 11 callers has a mean wait time of 16.7 minutes and a standard deviation of 2.7 minutes. The population is normally distributed. Is there enough evidence to reject the claim at alpha equal to 0.01? Use the rejection region method and show all work. So first, is either the population normally distributed or our sample size greater than or equal to 30? Well, our sample size is only 11. However, they do say that the population is normally distributed. So yes. The claim is at most 15 minutes. So that's mu is less than or equal to 15. So the claim is the null hypothesis. So the alternative hypothesis would be mu is greater than 15, which means this is a right-tailed test. Alpha is 0.01. Our sample size is 11, which means if we subtract 1 from that, we get the degrees of freedom, which is 10. Now let's look back at the table to find the critical value. This is a right-tailed test with alpha equal to 0.01. So we're in this column, and we have 10 degrees of freedom. So our critical value is 2.764. Mu is equal to 15. X bar is 16.7. S is 2.7. Next, let's calculate t. That's 16.7 minus 15 over 2.7 divided by the square root of 11. And rounded to 2 places, that's 2.09. Next, let's graph the critical value, the rejection region, and t. So this would be the rejection region. T is here. So for the decision, T is not in the rejection region. So we fail to reject the null hypothesis. So our conclusion is, at the 0.01 level of significance, there is not enough evidence to reject the IRS's claim that the mean wait time was at most 15 minutes.